Hello and welcome. In this video, we're going to take another look at our Introduction to Web Development series, and we're going to focus on the structures and the basic process behind the web client and web server communication. In addition, we're also going to take a look at some of the infrastructure required to facilitate web development. And so to begin with, what we want to do is we want to establish some fundamental definitions. And to start with, we're going to take a look at what is a client and what is a server. Now, in your mind, you've probably went ahead and thought about, for instance, maybe there's some significant differences in the hardware. Server is usually a lot more expensive. It's this abstract concept that sits somewhere off and you'll never see it. Well, the reality of it is that isn't the case. You want to think of the client and the server as roles, and the web client or the web browser basically is responsible for communicating to the web server, and it's going to make some sort of request to the web server. The server is then going to respond to that request and then send information back to the client. And so far, if you've noticed, I haven't really talked anything about the resources associated with either the client or the server. That's going to be dependent on the type of website and so on. The big difference between the client and the server is the expectations of the roles in those relationships. And so, for instance, a client could be shut down. In other words, you wouldn't expect the client to necessarily be up 24 hours, 7 days a week. And the server you would expect to be available, maybe not 24 hours, 7 days a week, but significantly more than the client. Also, the expectations implied would be that the server could accept multiple clients. All right. Now, technically speaking, that is not necessarily a requirement. Once again, it just depends then on what sort of load that you want to have on that particular server. And so you want to think of these terms, client and server, in rather abstract sense. Server is responsible for providing services to a client based on the client's request. And that's fundamentally the only difference between the two. Now, the types of relationships that we will be looking at are one client to many servers. In other words, if you are sitting here watching this video, you probably have multiple tabs open, and one of them may be to your favorite social media site or maybe your favorite news site, as well as perhaps to a learning management system and YouTube. And that is a great example of a single client being connected to multiple servers. You can also have many clients connected to one server. As you can imagine, there are plenty of people on YouTube right now, for instance, watching this video or possibly other videos. And so clearly you can have many clients to one server. You can have many clients that may access one site on one server, and you can also have one client that may access multiple sites on one server. And what we'll see is that you can actually have multiple sites being served out of a single server. Well, the natural extension of that is then that you could have many clients to many servers. That's essentially you and all of your friends browsing to multiple websites, including your favorite social media site, YouTube, and a learning management system. And technically, you can also have client-to-client collaboration or communication. That's more commonly referred to as peer-to-peer. Now, we're not going to take a look at that, but I just want you to be aware of that. That also will further confuse the issue, because then it sort of removes that distinction between what is a client and what is a server. So think of client and server more as roles rather than physical hardware. Now, thinking further with this, then the idea of this request response loop, the client makes some sort of request of the server, and the server simply responds back to the client. Now, if you've had a chance to watch some of the other videos, perhaps you've already looked a little bit at the idea of the HTTP protocol and the HTML markup language, then you'll appreciate then what's actually going on behind the scenes, and you've made some sort of request to the server for a particular web page, gotten some sort of response back, and then the client simply then displays that response. And what we want to do is we want to dig a little bit further into the two different types of websites. And so the first is going to be these static websites, or these more classic websites, where effectively what happens is you write an HTML page. You write all of the markup in a particular order. We'll talk about the order later. Don't worry so much about that. But the idea is that you've written this nicely formatted file using the correct syntax and the correct order. You've saved it and you've simply stored it on what effectively looks like a file server. And then you, from a different machine, you make a request of that web server to essentially serve you that file. And the classic example of this is going to be index.html, which is going to be the default web page for IIS and also for Apache. And the idea is then your web browser or web client from another computer, potentially, although it could technically be on the same computer, would make a request of your web server to serve then that page. And the server will retrieve the file. If it finds the file, then it will send it or stream it to the client, or it will send a message back that says that resource cannot be found. And we'll take a look at some of the codes associated with the HTTP protocol. We'll get plenty of time to look into that. You've probably already familiar with the resource not found. And then assuming that there is some sort of communication then between the server and the client, then the browser simply displays the response. Hopefully, if the file is found, it is going to be the intended result from the index.html. Now, with the dynamic websites, there's a little bit more going on behind the scenes. You still make the request to the server. In this case, class example of this might be to a file like index.php. And then behind the scenes, what happens is the server actually runs some code. And typically what happens is that code is responsible then for dynamically creating HTML syntax. And the idea then is that maybe you've made a query to your favorite site for purchasing something, maybe given some parameters, maybe the size or maybe the price or so on. And then what happens is the server then makes a query to, for instance, a database or some other external resource to that server. And then the response from that second machine then is then used by the script to generate the HTML file translation, or rather not just the HTML file, but HTML code. The HTML code may or may not ever actually make it to a file. In other words, it's going to be potentially streamed straight from the server then to the client. And so what does that look like? Well, imagine if, for instance, you went to your favorite shopping site, you've put in a price range of things, and then the results would come back to your client with some links and maybe some small pictures of the items that you're interested in purchasing. Once again, same situation with the static websites, get some sort of positive response with the relevant code, image files, etc., along with the valid HTML syntax that's all being streamed then from the server to the client. Or if the resource does not exist, then you may get some sort of error message. Either way, then it's the responsibility of the client browser to display the response. Again, the client browser does not have to be on a separate physical machine. However, though, it is implied that it is. So the types of servers that we're going to be taking a look at primarily are going to be web servers. However, there are other types. We'll take a look at two particular types of web servers, and if we get a chance to, we'll take a look at a third. Specifically, we're going to focus on the Apache web server and IIS. And if we get a chance to, we'll take a look at web servers like Node.js, or that can be started with Node.js. And their primary role is to generate and stream HTML code along with whatever additional resources might be required. So for instance, image files, audio files, and so on. Now, this is a little bit different than an application server. An application server can technically also stream things like HTML. It is probably more likely going to be streaming code or streaming content in a different language or in a different format, most common of which we're going to see are going to be things like XML, JSON, or even binary for that matter. But the idea is then these application servers are a little bit more specific in that they generally come with some sort of custom client. A good example of an application server that you probably never thought about was some of your gaming servers, or for instance, a license manager whose sole responsibility is to verify that you in fact have a valid license file for a piece of software. Continuing on with this, then database servers. Database servers are typically responsible for hosting large amounts of data in an organized fashion. We will later on in another series take a look at relational databases and how you would make queries then of a database server. The most common example of this is that you would probably keep information about a particular product, the price, the quantity at hand, and so on in a database server. And then what would happen is that you would make a call from your web client to your web server. The web server would then make a call to the database server. The database server would respond with the information that was requested from the web server. The web server would simply then be responsible for building the valid HTML code that then would be streamed back to your client. And like magic, you see the results of the query from your favorite shopping site. Some other types of servers are going to be the mail servers, although we won't take much of a look at this. Did provide you some additional information as far as the different types of mail servers, but that is, once again, another example of a type of server and service that would be provided on the internet, as opposed to just simply focusing on the World Wide Web, which is the role of the web servers. Additional types of servers include media servers. That may be audio from your favorite audio site. Best example of something along those lines would be a Pandora style media streaming service. The thing to note with the media servers is it is becoming more common to essentially have them as application servers, meaning that then you can connect with an app as well as with a web client. And essentially they use the same resource, but what you see as the client is considerably different. Authentication servers, in addition to authenticating users, you can also in some cases use them as authorization servers, or at least lump them together, although the roles are slightly different. We won't really dig too far into this in this particular series, but fundamentally authentication basically just says you are who you say you are, and an authorization server or service basically will check to see that you have the ability to access a particular resource. And so both types of servers are very common. In today's world, it's very common to delegate that operation to another entity altogether. A good example of that is using Google for authentication, or using even Facebook for authentication for a secondary service. And then last one, but definitely not the least important, as it does play a big role into how web development works, is the idea of the domain name system servers. And put briefly, effectively what a DNS server does is it simply maps a friendly name back to an IP address. The IP address is then given to your web server, and it may be changed as long as the DNS server has the updated record. And so if you think about it for a second, imagine if you had to remember a number to get to Facebook's website or to YouTube's website. Instead, what we have to do is we simply just type in youtube.com or facebook.com or uab.edu and so on. And once again, just like magic, your web client knows where to go. Well, it's not quite magic. In other words, what is actually happening behind the scenes is there is a request made from the DNS server to establish then what IP address to search for the particular resource. And so what you can think of these DNS servers, and there are a tiered relationship between them. So you can sort of think of it as a hierarchy, trust relationship between them. But the idea is that in these DNS servers simply provide you with some sort of mapping between the friendly names and the addresses of the resources you're looking for. Now, we've talked a little bit about the types of servers, which starts to get us into the infrastructure required to host and to hold these. And we won't take too much time with this because we're once again essentially using this as a customer. In other words, these are the things that we expect to have access to if we are doing web development, not necessarily something that we would be expected to set up ourselves. But fundamentally, what you want to do is you want to think of this in terms of data centers. You might have your web server, your web farm being hosted in a rack, multiple racks into a room. What makes these data centers so important is that typically they have air conditioning, significant amount of air conditioning to combat the heat generated by these physical servers. They typically have battery backups so that if the power goes out for more than a few minutes, that your website won't crash. And in some extreme cases may still be available to the outside world. And more importantly, or actually most importantly, these data centers typically have physical security. The best security you can have, whether it's in a website or any computer installation at all, is simply a lock on the door that requires having physical access. And so data centers are a very important part of this. Some additional resources that may be found at the data center or somewhere else offsite, depending on the network hierarchy, are going to be these network switches. Basically, what that does is those simply allow for you to have multiple clients connected to each other. From the perspective of web development, what you could imagine then is a rack filled with multiple physical hardware. Then each one of those physical machines are going to be connected to the network via these network switches. Depending on the type of establishment or the type of architecture that you're looking at, you may also have firewalls and virtual private network appliances. Once again, these start to get a little bit outside of the scope of what we're going to be interested in. But one thing we will want to consider are going to be load balancers. And the idea is that you wouldn't want to overload necessarily a single server or service, but rather that you would have this server or service spread over multiple physical or virtual servers. And the idea is then these load balancers can determine which one of them are free to take your request. And there's a couple of different ways that these can be implemented. For right now and for our purposes, you just want to simply think of them in generic terms. The big thing about load balancers is that is what has led us down the road of these cloud resources. In other words, we don't actually know which computer we are connecting to at google.com or at facebook.com. In other words, that's all just handled magically with these load balancers. And so they play a very key role in scalability of your system. What else do you get with respect to infrastructure and data centers? Things to consider are going to be redundancy in the equipment, redundancy in location. It would probably be a very poor idea for you to have all of your resources in a single location, particularly if they are critical. And so, for instance, you may want to have two data centers that are a few hundred miles apart so that, for instance, if a large natural event, natural disaster occurs, that doesn't impact both locations. The other thing to consider when it comes to equipment is going to be the redundancy of the equipment itself. In other words, perhaps your services or server are so critical that you may decide that you want to have additional hard drives, or in some cases, additional devices or additional servers as backup or hot swappable spares. Once again, just things to consider. And then lastly, the big thing that's changed over the last 5 to 10 years is the use of physical machines versus virtual machines. And the big thing that has changed there is that with some of the newer processors, you have much higher computational density per physical server. And what that means is that you can run multiple virtual servers on a physical server. And essentially your client, in other words, if you're a web developer and you're creating a website for a business, they have no idea whether their website is running on a physical machine or on a virtual machine. And so there's a couple of different ways that you can implement this. Also, just to note, and we mentioned it a little earlier, is the idea that a single web server can potentially have multiple websites on it. And once again, it doesn't mean that you have a single server for a single service. And it really, at this point, then depends on the amount of load that you expect for a given service. One of the last things I want us to take a look at then are going to be some of the resources that you'll find outside of your data center, and that is the ISP, or the internet service provider. Everyone should be familiar with that. That's basically how you get internet access and web access from your home. On the flip side of it is that you would also be how you then can host a website for someone, and that the idea is that your ISP then would allow for you to have a static IP address, and perhaps you would have to modify your firewall to be able to support that. The ISPs then, one of the roles that they play is they aggregate all of the traffic into these internet exchange points. The internet exchange points may be regional or maybe country level, but then what they do is they allow for you then to interact between different networks in different regions of the country or in different areas of the world. Now, this brings up an important aspect of this, and this goes a little bit back to networking and the idea of being able to route traffic. And so what you want to do is you want to think about it in terms of the differences between your home network and, for instance, you being able to connect to your laptop, to your wireless network, and then being able to magically go to your favorite website, but also then the ability to do the same thing when you're in a coffee shop tethered to your phone. And the idea is that you're going through multiple layers of these networks, going up and down, if you would, between networks. And essentially these routers exist at the borders between these layers. Now, this is a very generic description of them, but you want to think of routers as being fundamentally the interface between these two layers. One of their main roles is to aggregate traffic from one layer to another. And then along those same lines, we want to think in terms of that example of the coffee shop versus your home network. In the coffee shop, you may be combining things like wireless and cellular with classical wired, whether it's copper or fiber optic, and then in some areas of the world, satellite. And then the last thing I want to point out with respect to the infrastructure, and we will dig into this a little bit further, is the idea of the internet protocol or IP address mapping to the MAC address control or MAC address mapping. And once again, this is part of where the DNS servers play a role. At the IP address layer, then the IP address is the address that is given to a machine or to a resource. It can be a service, for instance. You can have multiple IP addresses for a single physical server. You can also have multiple network cards for a physical server, but each one of those network cards will have to have a MAC address associated with them. And so what this does is then allows for you to communicate through these switches from one switch to another by knowing what these unique MAC addresses would be. And so you can assign an IP address to a MAC address, and then that is kept in a registry that will allow for you then to communicate from one device to another. The DNS server's role in all of this simply allows for you to have a friendly name for an IP address. Now, if you think about it, not every device has to have a friendly name. For instance, you've probably never even thought about naming your laptop or naming your desktop. And so there's only certain types of resources that really require having a DNS server or DNS server entry. And the two most common of those are going to be web resources, such as your favorite website, as well as mail server resources. There are others, but those are going to be the two that you want to think about. So as always, if you have any questions, comments, or concerns, don't hesitate to email me, and thank you for watching.